Hi, welcome to MooMooMath. Today we're going to look at probability unit, the first lesson, using Venn diagrams. Okay, the first one we're going to look at is just what these symbols mean and how to shade the sections. Okay, so we've got this upside down U and then this right side up U, and we need to talk about what those mean. The upside down U means intersection, or what the groups have in common. The right side up U means the union, or collectively what do they have in common. So let's start by just shading these. So we have A intersect B. So we want to see what both A and B have in common. Where do they intersect? Well, that is just this section right here. So that means it's in both groups, both A and B. It's the intersection. So if that helps, we can even write the intersection. Okay, and how about A intersect B prime? Well, first we need to know what that B prime means. That little apostrophe by the B means it's not in B. So that means it would be everything outside of the circle B. So not in B, but in the box and in A. But it's got to be the intersection. So it has to be both in the outside and in A. So that means it's just in A, but not in B. So that means not B. Okay, how about this one? What is A prime or not in A? Okay, well, not in A would be everything in B, but not this section, right? Because this section is still in A. So it's going to be all of B, but then it's the other part of the diagram that's not in A is everything on the outside also. So we need to include that. So there you go. That is not in A. So you can see A is empty. Okay, now let's look at some unions. We have B union C. That means everything in B, including everything in C. So this is the union. Okay, so all of B union all of C. So that's A union C. So that's all this. Okay? How about this one? A intersect B intersect C. So it's got to be the intersection. In other words, it has to be an element in in A, B, and C. Well, the only section that's in A, B, and C is where all three overlap, which is this very small section right there. Okay, so let's look at one more of these. A intersect not B. Well, if it's not in B, it's everything in A and C, but it's also got to be in an A. So here we go. We're in A, but we're not in B. And there you go. That's how you do that one. Okay, now let's look at one put into practice. Okay, Mr. Grisham took a poll of his students' favorite type of weather. The students had the choice of hot, cold, and or rain and snow. The results are displayed in the Venn diagram. Okay, write the answer as a reduced fraction, and you always want to reduce your probabilities. So let's see, we have students that like cold weather, warm weather, and some that like rain and snow, and some that like different combinations. Well, we really don't care that much about the names. We just really need to know how many. Okay, so we have 6 students that say they only like cold weather. We have 2 students that say they like cold and warm. We have 3 students that like all kinds of weather. We have 4 students that like it either cold or rainy and snowy. Then we have 3 that only like rain and snow. We have 1, Bob, that likes warm weather or rain and snow. And then we have 8 students that like it only warm. So let's total this up. We got 8 plus 2 is 10, 16, 17, 18, 19, 20, 27 students. So we're looking at a class of 27, and that's very important. We need to know our totals. Okay, what's a probability that we're going to choose a student that likes cold weather? So we need to look in this whole circle. How many students like cold weather? Well, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16 of them like cold weather. So that's 16 out of 27. So this the whole group all together. Okay, how many people? What's a probability of warm prime? Okay, not warm. So we're going to take out all these students that like warm weather. Well, how many students is that? That's 8, 10, 11, 12, 13, 14 of them. 14 don't like warm weather. Well, how many are left out of the 27? 13 are left. So we had to take out the warm weather lovers. Okay, how about the probability of warm intersect cold? Either cold or warm, but they don't like this rain and snow, right? Cold intersect warm. Well, cold and intersect warm is this section right here, so that's 5 of them. 5 out of 27. Okay, how about probability of warm intersect rain? Okay, warm intersect rain and snow. That's the intersection. That's this part. What's that? 4 of them? 4 out of 27. How about warm intersect rain intersect cold, or warm intersect? Okay, so where's the intersection of all 3 circles? We have 3 of them. 3 out of 27. But be careful. This one reduces. This one reduces down to 1/9. So you want to reduce those down. Okay, the probability of cold union warm. So all my cold and all my warm. So let's count these up. That's 6 plus 4 is 10, 11, 12, 13, 14, 15, 16, 16, and 8 is 24. So I got 24 out of 27, which reduces by, what's that going to reduce by 3? 8/9. There you go. And that's how you would figure those out. Now let's look at the second page. The second page, we actually have to draw this Venn diagram. Let's see if we can do this. It says, Hector has entered the following names into his contact list of his cell phone: Alicia, Brisa, Steve, Don, and Ellis. Draw a Venn diagram to represent his contact list where event B is names that begin with a vowel. Event E is names that end with a vowel. Okay, so we have event B, we have event E, that begin or end with vowels. Okay, Alicia. Alicia, she begins and ends with a vowel, so she would go in here. So Alicia is common to both groups. Brisa, that one just ends with a vowel, so we're going to put her in this group, Brisa. Steve, he ends with a vowel, so he's over here in ending. Don. Don doesn't begin or end with a vowel, so he goes outside. And then Ellis. Ellis begins with a vowel. So we have Ellis is the only one that begins with a vowel but doesn't end. Alicia begins and ends. Brisa and Steve end with one, and Don doesn't start or end with one at all. So let's see, we've got 1, 2, 3, 4. We have 5 students we're looking at, right? So that's going to be our denominator. So we've drawn our diagram. There's our diagram. And then I'm going to put a box around the outside so you can see that Don is part of the problem. Okay, list the outcomes of B. So what are the outcomes of event B? Well, Ellis is the only outcome, right? Only possible outcome. List the outcomes of E. Well, B actually has 2, Ellis and Alicia. I'm sorry, I forgot the overlap part. Okay, how about list the outcomes of ending with vowel? Well, ending with a vowel is all 3 of these. That's what? Brisa, Steve, and Alicia. Okay, list the outcomes of B intersect E. In other words, beginning and ending with a vowel. Well, that's only Alicia. Alicia is the only one that begins and ends with a vowel. List all the outcomes of B union E. Okay, all of B, all of E, all together. So let's see, that's Ellis, Alicia, Brisa, and Steve. And then list the outcomes of not B. So who does not begin with a vowel? We have to take Alicia and Ellis out, so it's these 3, right? So it's Brisa, Steve, and Don. And list the outcomes of B union E not. So The union, remember, let's go back and look at number 5. The union was all 4 of these people. So who is not in that group? That's easy. Dawn. There you go. So that's how we're going to do our little Venn diagrams. So we kind of went over the concept of union, which is all groups together, or intersection, what they have in common, and then how we note not in a group, which is with a little prime. So if you see a little prime, that means not in that group. Hope this video is helpful.